My Today we continue with our topic that I think we stopped at absolute value last time. So today we will start with coordinate system. So coordinate system, as you can see from the slide, is a system which uses one or more numbers or coordinates to uniquely determine the position of a point, because this is a branch of geometry, and geometry is a branch of mathematics that deals with shapes and what have you. So coordinate system is a system which uses one or more numbers or coordinates to uniquely determine a point. So the simplest example of a coordinate system is the real number line, because on the real number line we have so many points: 0, 1, 2, 3, that is on the right. On the left I have -1, -2, -3, and the rest. So the real number line is obvious and the simplest example of a coordinate system. Also the Cartesian coordinate. The Cartesian coordinate is the plane, that is the XY plane. So it's also another example of a coordinate system. So for the meantime, we are going to restrict ourselves to the plane and some part of the real number line system. So Cartesian coordinate is another example of a coordinate system. So this is a coordinate system. I said X, Y plane. Normally we know these things from our high school, that is the x-axis and the y-axis. So this is a coordinate system. In the coordinate system, if we want to locate a point in a coordinate system, it is not like the real number line, because on the real number line each number has its points. But if we want to locate a point on a coordinate system, we will have a pair, that is a point from a number from the x and a number from the y, which will make something like a pair, just like this. A point in the Cartesian coordinate is represented by x comma y. So x comma y is one single point on a plane. So this is this point that I dotted with red, x1, y1. x1 is saying this x1 comes from the x-axis and y1 comes from the y-axis. So also this x2, y2 is also another plane on a coordinate system. So if you want to find or locate a point on a coordinate system, it's a pair. You have to have a number or a parameter from the x-axis and a number from the y-axis. So it's a pair. The pair will give you a point on a coordinate system. As you can see, this is an example. This red dot is saying this point is x1, y1, and the other red dot is saying this is a point x2, y2. If you look at it, there is a line connecting this point. So the next thing we are going to do is how we find the distance between these 2 points, because I have a point x1, y1, I have another point x2, y2, and it is joined by a line. We want to see how we find the distance between these 2 points, and the distance between these 2 points will be given in the next slide. So distance between 2 points. If you have 2 points on a coordinate system, there is a formula that we use to know the distance between those 2 points, and the distance, as we know, is always positive. We cannot have a negative distance, and unit of distance on this coordinate system is units. So we want to notice that if this is point x1, y1 and this is point x2, y2, we want to know what is this distance, that is from this to this. So this is the formula we use. The distance between these points, the points are x1, y1, x2, y2. We have 2 points, so we want to know what is the distance between these 2 points. It is given by the square root of x2 minus x1 squared plus y2 minus y1 squared. You have your x1, you have your y1, x2, y2. All you have to do is put it in the formula, find the distance between these 2 points. So this is the formula. So these are some examples. Find the distance between the following points given below. We have 3 examples, and in each example we are given 2 points, and all is asked of us is to find the distance between these 2 points. So let's see how we solve this simple example solutions. Number 1, we have point 1, 2 and point 3, 1. So recall that the distance between 2 points, that is x1, y1, is given by this square root of x2 minus x1 squared plus y2 minus y1 squared. And look at the example. X1 is the first letter here, first number here. X2, y1 is the, because I have a point x1, y1, a point x2, y2. In each pair, I have x1, y1, the next pair x2, y2. So don't be confused. Don't take this pair as x1, x2. No. If you say x1, x2, that is not a point on the coordinate system. It has to be x, a point from x, and from y. Then it will give you a point on the coordinate system. So don't mix it. x1 is 1 and y1 is 2. That is for the first point. And x2 is 3 and y2 is 1. So all you have to do is substitute these values into the formula as given here. Substituting the values in the formula, we have the distance is 3 minus 1 squared plus 1 minus 2 squared. The rest is arithmetic computations. 3 minus 1 is 2 squared. 2 squared, you have 4. 1 minus 2 is minus 1, and minus 1 squared is positive 1. So here you have 2 squared plus 1 squared, which is 4 plus 1, which is root 5. So the distance between the point 1, 2 and 3, 1 is square root of 5 units. That is all. All you have to do is find x1, y1, x2, y2 from the given points. In the first point, you are given x1, y1. Second point, x2, y2. Just substitute it into the formula and you will have your answer. The next example is we are given the points 1, minus 1 and 0, 1. So look at it carefully. X1 is 1 from the first point, and y1 is minus 1 also from the first point. And from the second point, x2 is 0 and y2 is 1. So this is this. So the distance is given by the formula. It is there. So substitution, you will have 0 minus 1, which is minus 1. And you have 1 minus minus 1. 1 minus minus 1 is 1 plus 1. So 1 plus 1 squared is 2. 1 plus 1 is 2. 0 minus 1 is minus 1. So evaluate this. Minus 1 squared is 1. 2 squared is 4. You have 1 plus 4, which is also square root of 5 units. So the distance between 1 and minus 1, 1 minus 1 and 0, 1 is square root of 5 units. So the next example will also be trivial if you just apply the formula and you pick the values of x1, y1, x2, y2 correctly. So next, we have a line. Like I showed, we have a line, a point, and a line connecting them. We show how to find the distance between these 2 points, which we can say technically is the length of the line. We can say that the distance between 2 points. Now we have a point. We want to know how to find the midpoint. Point here and the point here. How do we find the midpoint? We showed how to find the distance between these 2 points. How are we going to find the midpoint between these 2 points? Well, this is given the midpoint formula in the Cartesian coordinate. Given 2 points, x1, y1 and x2, y2, the midpoint between these 2 points is given by x1 plus x2 over 2, y1 plus y2 all over 2. And remember, we are on a Cartesian coordinate system. I have x1, 1 point here, 1 point here. I want to know the midpoint please, this time around, we are not finding the distance. It should not be in units. Midpoint is going to give us a point on the coordinate system. And a point on the coordinate system is a pair. We have a number from the x-axis and a number from the y-axis that will make a point on the coordinate system. So distance is a number which will be in units, but midpoint is going to be a point, and a point on the coordinate system is a pair. So this is the formula. The midpoint between these 2 points is given by the formula x1 plus x2 over 2, y1 plus y2 over 2. So example, find the midpoint between the following points. Now 1 and 2, let's see the solution. Solution 1, 2 and 3, 1. Here we have x1 as 1, y1 as 2, x2 as 3, and y2 as 1. So all is required is put the input, substitute these values into the formula, and you have 1 plus 3 over 2 and 2 plus 1 over 2. 1 plus 3 is 4, 4 over 2 is 2. 2 plus 1 is 3, 3 over 2 is 1.5. So the midpoint is 2, 3 over 2. This is what I mean. The midpoint will give you a point, a pair, but the distance will give you just a single number. So we take note of that. So the midpoint of this point is 2, 3 over 2. The next example, I have a mixture of minus, minus. So that is why I use a color with red, purple, and green to differentiate the values of x1 and y1 and x2 and y2. So I use colored. If you look at the PowerPoints, you will see that we have some colors to differentiate. So the point is minus 1, minus 2, and minus 1, minus 1. These are the points. Now x1 is minus 1 with green, y1 is minus 2, yeah, with purple, I think, and x2 is minus 1 with dark blue, and y2 is minus 1 with red. So I did this to differentiate the selection, because one may get confused. The minus 1 you may not know is for x1, you may not know is for x2 and y2. So with this colored, I think it will help. So x1 is minus 1, y1 is minus 2, x2 is minus 1, and y2 is minus 1. So recall the formula, put it, you have minus 1 over 2, minus 2 minus 1 over 2, minus 1 is minus 2, minus 2 over 2 is minus 1. Also minus 2 minus 1 is minus 3 over 2, you have minus 3 over 2. So this is the midpoint. So these are some exercises for you to practice. Find the distance and the midpoints between of the following point. I mean, find the distance between these 2 points and find the midpoints of this and this. So that is why I use the slash. So try solving these exercises and you will find them interesting. So now the slope. We have shown how to find the distance between 2 points on a plane, and also we have shown how to find the midpoint of if we are given 2 points, how we find the midpoint. So now we are going to see what is a slope. That is on a plane. We know what we have been using, the word slope, slope, slope. So let's see what it means. One feature of a straight line is its steepness, because if you look at these 2 lines in the figure below, I have a line with green and the other one with black. So they are all lines. They are obvious and they are straight lines. So one feature of a straight line is its steepness. Let's see what is a steepness of a line. For example, we have these 2 lines. Please note that the first one is this and the first one is looking this direction. So the line with the black color rises faster as it goes from left to right. This is the first line and this is the second one. This will rise faster than this if they are going from left to right. So in this case, we say the black line is steeper than the green line. I have two lines, this and this. This one will rise faster at its move from left to right, and also this one will not be rising as faster as this. So we say this line is more steeper than this. That is steepness, how far our line rises. So to measure the steepness of a line, we use the notion of a slope. If we want to know the steepness of a line, all we have to do is see what is the slope of that line. So this is why we study slope, and this is why we need steepness. We need steepness, and to define how the steepness works, we need to know what is a slope. So the slope is called the rate of change. It has so many names. We call it the gradient, we call it the rate of change, we call it the slope, and some we call it dy dx. That is the first idea of differentiation, is the slope. So we call it rate of change, slope, and gradient, and it can also be found, it can also be called the derivative of a function at a given point. That is the slope of that function at that point. So it has so many names. So if you are given also 2 points, you have a line, and let's say you have 2 points on that line. This is my line and this is my 2 points. So we are going to use those 2 points on a line to find the slope of that line. We are going to use the points on a line, arbitrary points on a line, to find the slope of that line. First, you have a straight line and locate, let's say, 2 points on the slope, on the line, sorry. So we want to know the slope of that line. So if you are given the 2 points, x1, y1 and x2, y2, then slope m is change in y, because we are dealing with the x-axis and the y-axis. And to have a point on a plane, I said you need a representative from the x-axis and also a representative from the y-axis. So the slope, usually we use the letter m to denote the slope. The slope m is equal to change in y over change in x. This brought the idea of del y del x, because delta is change. So del y, delta y over delta x is change in y over change in x. So delta y over delta x. Okay, y has 2 points, y2 and y1. X has 2 points, x1 and x2. The change in y is y2 minus y1. That will give you the change, and the change in x will be x2 minus x1. So this is the idea, the formula of a slope. The slope of a line is given by change in y over change in x, which is y2 minus y1 over x2 minus x1. Okay, I have a slope, a line, sorry, like this, slant line, which is neither vertical nor horizontal. So let's see what is the slope of a horizontal line, a horizontal line and a vertical line. So the vertical line does not have a slope. Why? This will be an interesting exercise for you to check. Why do we say so? Why do we say so? The vertical line does not have a slope. Maybe there is no change in x. I don't know. You need to check. I know it, but I want you to check. Maybe the change in x is something. Maybe there is no change in y. Check. Just check. Check what is the change in y and what is the change in x. One of them will, if you substitute in the formula, will give you something that we don't know. So the vertical line does not have a slope. Please, this is an exercise. Submit what you, if you check the reason, please. I want to see the reason. Just send me the reason. The vertical line does not have a slope, and the slope of a horizontal line is 0. Slope of a horizontal line is 0. Vertical line does not have a slope. I want to know the reason why I say these statements, these two statements. So please find out. So please just look at the formula. If you are given 2 points and 2 points on a line, and you are asked to find the slope of that line, apply this formula: y2 minus y1 over x2 minus x1, just like this. This is a Cartesian coordinate with p, q, you can call it price, you can call it quantity, p, q, p, let p be price and q be quantity. And look at a line. I have a line, a straight line moving this way, and I have 2 points. So with dot, this black dot, I can use 2 points to find the slope of this line. Yeah. So look at it. The line in the figure above shows the relationship between the price of a commodity in dollars and the quantity of commodities in thousands the customer will buy at that price. So you have a price of a commodity and you have quantity in thousands, price in dollars. So if the first point on the line is 2,4 and the second point is 8,1, that is, these black dots, let's say the upper one is 2,4 and the down one is 8,1. How do we find the slope? The slope m is given by y2 minus y1 over x2 minus x1. Look at it carefully. X1 is 2 and y1 is 4. X2 is 8 and y1 is 1. So put it, y2 minus 1 will be 1 minus 4 over x2 minus x1, 8 minus 2. This is equal to minus 3 over 6, which is minus 1 over 2. So since we are dealing with price and the commodity, this is an application in economics, price and the commodity, this negative slope has its meaning. Yes, it has its meaning. This negative 1 over 2, it has its meaning, which is relating the price and the commodity. So in our next video, next lesson, I will we will discuss what the meaning of this negative slope means to the price and to the commodities. So this is the end of this video. So we meet next week, and after next week our final exam will next week will be our last class. So the final exam will be maybe on 26th. I will send you the time and the date of the final exam. So thank you and bye bye.